Okay, good morning. Welcome back. I hope we're having a wonderful week. Our quick look at the calendar, and then we'll review for our test. Today is our review day for test number 2. Test number 2 is Monday. Test number 2 covers everything after test number 1. So all the stuff from here down to here. Any questions on what is covered on test number 2? And again, in terms of organization, all of packet 2 is test number 2. All right, and one thing I'll point out just while we're here, because we've been doing Trig so long, it's easy to forget that we actually spent a couple of days before we started doing Trig after the first test. We had power and polynomial functions, and then we had the comparing different kinds of functions, end behavior, and the hierarchy of domination stuff. So make sure that as you are studying, you don't only do Trig, spend some time doing the stuff at the top. So on page 50, we'll go ahead and just list some of the subject areas here in the middle. Can we start with Emily, number 1 in the middle? On page 50. Okay, and again, that's like kind of a bullet point thing. It's really short, but there is a much longer list. If you go back a few pages, we'll take a look at it in a minute. We'll go to Sam for number 2. Okay, so just to be clear, there were a couple of Trig reference sheets that were in the packet someplace. We've used them on quizzes. It's time to not use them. You can bring in your unit circle and then anything you want on a separate piece of paper, but that's it, 2 pieces of paper total. And also in terms of the no calculator section, it's going to be the same setup as the first test where it'll just be a 1 page that is no calculator, and you can decide to do that at the beginning or in the middle or at the end, anytime. You just trade me your calculator for that part. We'll do it just like we did on that table in the corner. The no calculator part is 20% of the test. The calculator part is 80% of the test. Go to 3, Todd. Okay, so you can show up any point in there, but I'm going to do a better job this time of holding the line at noon. I know that some folks had to leave at noon, but would have liked to have stayed and wanted more time, but had to go, and didn't think it was fair that I kind of changed my mind about extending that window. So 10 to noon, get here at 10, we'll start right away and do what you can in the 2 hours. Number 4, Stephen? Okay, so this stuff is due Wednesday. Our test is Monday. This is due on Wednesday. You're going to read and you're going to answer 3 questions of the day. There's no homework assignment due for Wednesday. Any questions on any of that? Okay, so then let's just go back a few pages and we'll find the sample test problems. I just want to point out the resources. So on page 43, so most of page 43 is this list, very detailed list of the stuff that I'd like you to be able to do by the time you get to the test. And if you go to the next page, you'll find our sample test problems. And you can see, for example, even here, number 1, I'm giving you something like part B, 1 over 4x squared. Is it a power function? Is it a polynomial? What is the end behavior? Stuff that has nothing to do with trig, but that we covered after the first test. So make sure that you spend some time thinking about that. This is the oldest stuff, and it's real easy to forget that we talked about it at all. So what I'd like to do before I have you guys work on any of those that you'd like is I want us to work on one together. This number 13 here on page 47. So jump to page 47. We're going to do 13. And I just want to point out again that the videos of me going through each of those sample test problems are on YouTube. So check it out. If, for example, you type in 108 sample test 2 problem 4, you will find my video for that particular problem. Okay, just change the last number. You'll find them all. So I wanted us to do this one together because, again, it's my third time teaching pre-calc here, and for the third time in a row, I'm not thrilled with how inverse trig went, and so I just want to make sure we have at least one more time together where we can do some inverse trig. This is the hardest inverse trig thing I could possibly ask you, so I figure if we can do this one, then we should be okay. Can we go to Topher for 13? Okay, so let's try this one. We've presented a couple of different ways to solve inverse trig. I'm just going to do one way here, and if you like this way, great. If you prefer one of the others, then do that. So we're looking to take that equation, and how do we handle this 29 feet? We put d equals 29, right? We want that whole equation to equal 29. Is this a good time to do inverse sign? What needs to move first? 32 needs to go over first. So subtract it from both sides. And then what needs to move? 7. Divide both sides by 7. So that's 2 steps to get the trig function isolated. Now what should we put in front of both sides? Inverse sign, arc sign. So I'm going to write it before I use the calculator. So we go inverse sign of -3/7 equals t. Oh, that's not right. What should it equal? Pi over 6t. Now it's the inverse sign. Thank you. Okay, and we'll type that into the calculator. If you hit the sign button or the inverse sign button, what do you need to think about? Is your mode. This problem doesn't say anything about what mode you're in, so do we get to pick? Probably radians because it's not marked. And that pi in there is a good indicator that we've got radians floating around. All right, so make sure your calculator's in radian mode, and somebody give me an answer here. We got pi over 6t equal, or is approximately equal to? Okay, so I'm just going to call it -0.44, and you guys can carry more decimals by keeping them on the calculator. Now that -0.44 is one answer. How many answers are there all the time? 2. Right? There's always 2 fundamental answers, 2 basic answers. And this is the moment right here. It's very tempting to divide by pi over 6. But if you do that, you're going to kind of mess up the -0.44. That angle needs to stay intact. We can find the other angle based on that, and then we'll solve for t at the end. So to find the other angle, I like the unit circle. So I will draw my unit circle flawlessly. I know. -0.44, let's see. So that's -0.44 radians. You guys hold up the number of fingers. That is the quadrant that -0.44 lives in. We've got a few votes. I would like to see some more votes before we move on. So which quadrant is this? All right, so it feels like it's in the fourth one. That's the right answer. So we'll put negative 0.44 here. That's this angle. And now we got to find the other one, the other fundamental answer. And I'll say that, I mean, it's either up there or down here. It's one of those. So we got to pick the right one. All right, so what do we think? We've got sine was supposed to be a negative number. In which quadrants is the sine a negative number? 3 and 4. Everybody see what we just said? We had the sine was a negative. We're in quadrants 3 and 4. No surprise, we got an answer in quadrant 4. We need the other one in quadrant 3. So if negative 0.44 is there, then how do we find the true angle, the full angle going in the third quadrant? Pi plus 0.44, not negative 0.44, pi plus 0.44. Okay, so that will be our other answer. So the red angle is pi plus 0.44 dot, dot, dot. So what do we get there? 0.58. Call it that. Okay, I'm going to copy my first fundamental equation. That was the minus 0.44 one. And then the new fundamental equation, the other one, is what? 3.58. We found out that's the other angle that gives you the same sine value. So I've got my two basic angles. Now you see I've left some space in there. I'm trying to lead the witness here. What should we stick in that space? So we're going to divide by pi over 6, definitely. But before we do, yeah, like there's this plus 2 pi business, right? We could have taken any number, like 3.58 is only one answer that lands you on the same angle. So why am I putting in this plus 2 pi k? Well, the problem originally said find how many answers? It said find the first 3 answers. Well, this is my way to kind of generate them in a table. That's an easy way to generate all the answers, is to grab them all here. And then we'll divide both sides by pi over 6. I don't really like dividing by fractions. What could I multiply by? 6 over pi. So let's multiply both sides by 6 over pi. So we get 6 over pi times negative 0.44 plus, and then we're doing 6 over pi times the other guy as well. And if I do that, we should have our hands on a formula for t. And we do the same thing down below. Mm-hmm. You could do minus 2 pi k every time, but it has nothing to do with the fact that this is a negative 0.44. Like negative 0.44 is just some angle. It's this angle right here. You can write that any number of ways. You can do it plus 2 pi k or minus 2 pi k. Lots of right answers. Okay, so we'll get the calculators out again. What do we have for this first one when we multiply by 6 over pi? 0.9 or something? 0.84? And then plus, and then we'll go ahead and clean this up because the pi's cancel, not just kind of a coincidence here. So I think we just get a plus 12k. And then on the bottom one, what do we get when we multiply? 6.8. Okay, and just so we can tell these two fundamental solutions apart, I'm going to call the first one T1 and the second one T2. They're both times, but I'll just distinguish them so I can make a table. And then I think all we have to do is fill in the table. Almost all the time I start with k equals 0 and then proceed. So we'll try 0, 1, and 2. Let's see how many we need to go to get all our solutions. If we plug 0 for the k in the first one, negative 0.845. 0 in the second one, 6.85. And then we plug in k equals 1 into both of them. So what do we get? 11.155. And then down there, 18.85. I think we're done. What were we looking for again? First three after midnight or something. So the first three positive ones were what we were looking for, and we got them. So we're done. If you want more, fill in more of the table. That's right. And maybe to make it a little more user-friendly and less like straight math, whatever it is, 6 a.m. and then change 0.85 hours into something useful like minutes. Have I talked to you about the movement to change? It depends on what the question asks. If it says how many hours, then these are the answers. Find the first three times after midnight. It feels like 6.85 is not a standard way to write a time. So if you just do the 0.85 times 60 minutes. I don't understand, because like that tangent just comes up every time. And what are we doing? 0.85 times 60 minutes in an hour. So 6:51 a.m. is what that first time really is. Have I talked to you about the movement to change the definition of seconds and minutes and hours? No? It's a pretty small movement. But it is not very friendly that there are 60 seconds in a minute. 60 is just not a nice number to do calculations with. Likewise, 60 minutes in an hour is not very friendly. How many hours in a day? 24, not friendly. It's natural because that's what we've known our whole lives, but 24. I mean, like if I just said how many seconds are in a day, you have to do work, right? So how about we just change everything to what's the nicest like base to like 10. Like everything we do is base 10. Why are we playing with 60s and 24s? So how about we redefine it so that there are 100 seconds in a minute, 100 minutes in an hour, 10 hours in a day. And it turns out by doing that, so I said, so let's figure out how many seconds are in a day currently. So what do I do to find how many seconds in one day? So 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. Okay, 86,400 seconds is in a day currently. If we do it my way, I said, well, I mean, we don't need the calculator, but just so we have it up here, I said 100 seconds in a minute, 100 minutes in an hour, and 10 hours in a day. It's not all that different, right? Things would change. A second would get slightly shorter. I'm not wedded to the concept of a second as it's currently defined. So seconds would get a little bit shorter, but it wouldn't become like half as short. We would hardly notice. The hours would be longer because there's only 10 hours in a day now, right? But at least we would have a sense, like if I said, what time is it now? Well, it's exactly 11, so that's not so nice. But if it's 10:37 and I say, I'm going to come back here in 45 minutes, carry the 1, right? Like it's annoying to do stuff with 60s and 24s. So if you If you see petitions, like sign them so that we can get this going. Topher. They tried this setup here? I need to. Uh-huh. Like that's some weird weak thing that happened every few years. So it was like it made sense in the short term, but in the long term it got really complicated and got tired of it. Huh. Why would the number of days change? Oh, because the days would be longer. No. The days are the same. It's not. What I'm redefining is not how long a day is. I'm redefining how long a second is. I'm making the seconds a tiny bit shorter. I don't have to change much, but just make the seconds a little bit shorter. Still, the day, you know, like waking up at 8 a.m. today is the same as waking up at 8 a.m. tomorrow. Well, let's talk. I want to come back to pre-calc stuff, but we'll talk. I will answer that question with you in 1 minute. Yes, Stephen. How long would a workday be? 8 hours, is that right? So 8 hours is a third of a day. So that many seconds. Divide by, what do we say, 100? That many minutes? 333 minutes. That's not so bad. Okay. Are there questions on this? All right, so then I propose in the last 48 minutes of class, we're going to, we'll have you guys work on any of those sample test problems with your neighbors. I will walk around and see how far we can get.